In this video, we're going to talk about graphing Limacons. I think that's how you say that. It's a French word. So these are going to be of the form, and I'll show you on this page. These are going to be the form. We're going to have two numbers here, a plus or minus b, and then either sine theta or cosine theta. Okay, so we've got this number in front, and we're either adding or subtracting some number times sine or cosine. This is what these things are going to look like. They're kind of circular, more than anything else, but they could have these kind of dimples, or possibly even an inner loop inside of them. Okay, so we're going to talk about how we're going to get those different shapes and things like that in this video. So we've got an example, 2 plus 2 cosine theta. So the first thing that we're looking at is the trig function. Okay, is it sine or cosine? So we've got cosine here, which means it's going to be oriented horizontally. Okay, it determines the orientation. The ratio of a to b. Okay, so this is a and this is b. Okay, so we've got a equals b, and I'm going to go back to this page. If a equals b, then we are looking at what is called a specific a cardioid. Okay, is what we're looking at here. All right, so I'll go ahead and write that. We're looking at a cardioid. A plus b. So I'm just going to write these numbers down, then we'll show what that looks like on the graph. So a plus b is going to be 4, a is 2, and a minus b is 0. And when I do these, I'm ignoring all negatives. So if either one of those were negative, I'm just ignoring that, and then I'm going to adjust that for my graph based on what I know about the orientation. So if we have both positive here, and the cosine is our trig function, the high point, which is what's going to be the a plus b, we're going to call that the high point, is going to be out to the right. Okay, so what I'm going to do is I'm going to go out to the right 4 and put a point right there. Okay, the a value, which is 2, is what we call the stretch on the opposite axis. Okay, so our main axis here is the x. We're going to go out 2 on the y-axis, both directions, and put a couple points there. Okay, and then the a minus b, the 0, is what we're going to call the low point. Okay, so the low point wants to be away from the high point. And so if our low point is 0, that's just telling me that my low point is going to happen right here at the origin. I'm not actually going to go out to the left any. It's just going to be right there. And you can see that in this cardioid shape, that low point is going to be on the origin. This one's just oriented vertically. But if the a equals b, then that low point is going to be right there at the origin. Okay. Once we have that, we're going to go ahead and make our graph. Now, you're going to be very tempted to make this look like a heart. Okay, it's really hard to see the circular nature of this. When you do these, and I'm going to talk about it because it'll be easier than me graphing this. This is not as wide as the graph gets. Okay, so we start here, we go out wide, and then we come back through that point, and we're going to have a dimple here, and then we're going to go through this point, get out wide again. Again, you want to try to make this as circular as possible. Hopefully it's easier for you to do this than me, but it should look something like that. Okay, a lot of people they think that this is as wide as the graph gets. It gets out wider and then comes back through those points. Okay, so there's an example of a cardioid. Here we have an example where there is a negative. Again, I'm going to ignore that when I do all these values here. We also have sine. Okay, so this time it's sine. The orientation is going to be vertically. Ratio of a to b. So a is 3. And b is 4. So we have a is less than b. If a is less than b, we've got this scenario. We're going to have an inner loop. Okay, and we'll see how we get that inner loop. We're going to have an inner loop. Write that so I remember to do that. A plus b, again ignoring the negatives, that's going to be 7. A is 3. And a minus b, we're doing 3 minus 4. That's going to give us negative 1. Okay. Now, I should have given you some better numbers here because we only have 5 rings, but we'll pretend like we have 7. We'll just make it go out further. Okay, so once again, A plus B, that's the high point. And then this is our opposite axis stretch. And then this is our low point. All right, so it's sine and it's minus. So that minus is going to tell me that my high point is actually going to be down. Okay, so if it's plus, the high point's at the top or at the right if it's cosine. If there is a minus there, the high point is going to be down. If it's sine, it's going to be to the left if it's cosine. So I'm going to go down to about where the 7th ring would be, which would be right around here. And I'm going to put a point. That is going to be my high point of my graph. Okay. The stretch on the opposite axis is 3. So now our opposite axis is the x-axis. I'm going to go out 3 and 3. And then our low point. Now, remember, our low point wants to be away from the high point. So we want our low point to go up. Yeah? But because my low point is negative, the low point, again, wants to be away, but because the low point is negative, that means we're going to go back towards the high point. Okay, so that negative is going to tell me to go towards the high point instead of going away. Okay, and I get that point there, and that is going to be like the top of the inner loop. So anytime that low point works back towards the high point, you're going to get that inner loop going on. Okay, so with those points, I will do my best to make this graph. I'm going to go out wide, go through here. I'm going to make my loop, come back wide again, and go back through there. And that would be our graph for that one. So a couple key points. If A minus B is a negative number, low point towards the high point. If A minus B is a positive number, then you are going to work away from the high point to create that. Okay, so that is graphing Limacons.